Now come to the last algorithm, which was optimal page replacement algorithm. To realize the working principle of this algorithm, we need a little discussion. Actually, if you look into the process scenario, for most of the processes, unless the process is hugely dynamic, what is going to be the process sequence is or will be already known to the CPU prior to computation. Let me write the line what I've said. For most of the computation, the page string sequence will be known to the processor prior to computation begins unless the situation is highly dynamic. Just look into the line and give it a thinking for a little while. If you cannot figure out the situation, how this occurs, just pause the video here and think about this. As you can look into normal programs, day-to-day programs that we do, you will find that most of the computation task is static. So the process sequence is essentially will be known to the processor before the computation begins onto those page sequences. So essentially when CPU is going to process a page which has index say 4, it will have ample time to look into the future page sequences which are there into the stream. Optimal algorithm actually try to take advantage of this thing. So let me try to understand what will be the scenario if we use optimal page replacement algorithm in this problem. Optimal page replacement algorithm instead of FIFO or LRU in this problem. Now page sequence is essentially the same and number of page faults at the beginning is 0 as the condition is given. Frames are initially empty. Now before the computation begins, I repeat it once again, before the computation begins, processor already knows the page index sequence, in what sequence pages are going to arrive. So at the beginning, as the frames are empty, essentially there will be a page fault. So when CPU asks for this page with index 4, the start page fault occurs and page is pushed into the first empty frame. Then move to the next page which has index 7. Again we have a page fault like the previous two algorithms. So increment the number of page faults variable by 1 and push the page with index 7 into the next empty frame. Then move to the next page which has index 6. Page fault is once again there. Increment the number of page faults by 1 and put the page into the next empty frame. Now next required page has index 1 which comes after page 6. Here the problem comes. The page with index 1 is not available into the RAM, so page fault is there, and when you try to introduce this page into the RAM, you find that the RAM is already full. So you essentially need to replace one existing item with the new item. Now what should be done? The algorithm is optimal page replacement algorithm. As we have discussed before, it actually looks into the future. That means what pages are there into the sequence after the present page. Present page is 1. For a while, let me go back to the tools. Virtual laser pointer. Here. Now we are at page 1. This needs to be introduced into your RAM by replacing one of the existing items. And before replacing the existing items, processor will look into the future. Existing items into the RAM are 4, 7 and 6. And in near future, after page 1, page 7 is going to be used once again. After that, page 6 is going to be used once again. But this page 4 is not going to be called in near future. So, to introduce page 1 into the RAM, this page 4 should be replaced. Let me go back to the desktop. So by following this optimal replacement policy, replace page 4 by page 1 and increment the number of page faults by 1. Now you see, when you come to the next page which has index 7, you don't need to replace anything. Next, come to the next page which is page 6. You again don't need to replace anything. Then come to the next page which has index 1. You again don't need to replace anything by following this optimal page replacement algorithm. Now come to the next page. It has index 2. You can notice it here. Again, what you have to do? You have to look into the future before replacing the existing items into the RAM. Next item is 7. So, don't replace 7 from the RAM. Next item is 2, which is not into the RAM yet. So, as the next future item is 7, which is going to be called after page 2, don't replace it. Replace anything other than 7 from the RAM, which are not going to be called in near future. For the time being, let me replace 6 and replace it with page 2 and increment the number of page faults by 1. So, after page 2 has been introduced, in the sequence we have page 7, but to introduce page 7 we don't need to replace anything. There is no page fault. It is already into the RAM. Let me move to the next item. It is page with index 2. Again, we don't need to replace anything, and there is no page fault as there is no page fault. So our sequence has been fully introduced into the RAM. Now let me add the total number of page faults. It is 5 using optimal page replacement algorithm. If you can recall the number of page faults using FIFO or LRU, it was 6. Using FIFO, we had 6 number of page faults, as well as using LRU, we had total number of page faults which had occurred was 6. But here we have 5 number of page faults using optimal algorithm, which actually looks into the future. So if you compute the hit ratio and miss ratio using this method, you can see that now the hit ratio and miss ratio has been improved by 10%. Hit ratio has been improved by 10%. So we can conclude from this discussion that optimal algorithm is essentially better than FIFO and least recently used algorithm. Now what will be your task? Your task will be to implement this discussion yourself in your copy and try to realize this thing, how this entire thing happened. Thank you.